All right, going to take you through the review for Chapter 10, Algebra 2. Here we go. Number 1, binomial event has 60 trials. We want the mean and the standard deviation. Again, mean is n times p, which in this case would be 60 times the 0.4 probability mean, which is 24. And standard deviation is the square root of n times p times q, which is the square root of 60 times 0.4 times 0.6, which comes out to be 3.79. So the answer is A. And number 2, discuss this in class. We want the probability of getting at least 10 threes out of 50 rolls. Now, if we want at least 10, that means we want 10 to 50, and we don't want 0 to 9. So we need to find the answer that does 1 minus 0 to 9, and that would be D. 1 minus the probability of 0, 1, all the way up through 9. So the answer would be D. For number 3, the weights of professional football players are approximately normal, distributed with a mean and a standard deviation. If Thor is at the 80th percentile, we know this is normal, and they give us a percentile, so we're going to key in our calculator inverse norm, and we're going to put that percentage, 0.8, comma, the mean, which is 245, comma, the standard deviation, which is 20. And when we punch that into our calculator, we get about 262, which is our answer. Number 4, Chanel got the same score, 51, on back-to-back quizzes. Okay, and it gives you the mean and standard deviation from both quizzes. We need to know which one she does better on. To do that, we find the z-score of both of them. So 51 minus 43 on the first quiz, her score minus the mean over the standard deviation, which is 8 over 6. And then the other one, we had a mean of 38. So that is 51 minus 38 over a standard deviation of 9. This one would be 13. So 13 over 9. So the question becomes 13 over 9 or 8 over 6, which is a larger decimal? And the answer I'm going to use my calculator to show you the decimal. Hold on one second. Got it? 8 over 6 is 1.3 repeating. 13 over 9 is 1.4 repeating. Therefore, she did better on quiz 2. So your answer would be B, or you could say D. Same answer. Okay, for number 5, we wanted to know, to the nearest tenth, what score was achieved by the student was in the 90th percentile. Once again, we're given the percentage, so we're going to bust out the inverse norm. We put in the percentage, which is 0.9, comma the mean, which is 2.05, comma the standard deviation, which is 1. Punch that into our calculator, and we get 3.3. That is the score of the 90th percentile. For number 6, Dolores is shooting free throws. Probability she makes exactly 7. Exactly 7, we're going to use a binomial PDF. That's what you use when you want exactly. 10 total free throws, probability of success being 0.65, probability of failure being, or I'm sorry, not probability of failure. The number we want is 7. Punch this in, and we get a 0.2522 probability of 7 free throws being made. Probability she makes less than 5. So that's the probability of 0, 1, 2, 3, and 4. Since that's the low end, we're just going to use binomial CDF. 10 total free throws, comma, 0.65 probability of success. And we're going to put a 4 here. Since it's a CDF, it will add the probabilities of 0, 1, 2, 3, and 4 and give us 0.0949 or 9.5%. See, what's the probability she makes at least 8? Well, that means we want 8, 9, and 10. Since we want the high end, we're going to do 1 minus binomial CDF. And since we want 8, 9, and 10, I'm going to subtract out 0 through 7, and I'm going to do that by doing CDF with a 7 here. 1 minus that gives you a probability of 0.2616. C, the mean, again, n times p, which is 10 times 0.65 So we have a mean of 6.5. In the standard deviation, the square root of n times p times q, which is the square root of 10 times 0.65 times 0.35, which is 1.508. On to the next page, number 7. I told you guys could skip this, but for a distribution, or I'm sorry, for a, what is it? A sampling distribution, all you have to do is put an n down, and then you put the mean, which is 65, and you put the standard deviation, okay? But for the standard deviation, you take it and you divide it by the sample size, which is 15, the square root of that. So this would be what it is. You guys already know how to do that. I'm not going to ask you to do a question like number 7, but if I did, that's what it would be. Okay? Number 8, we want to know the approximately normal. So now it's normal time. We're not in the binomial now. Greater than 11.5 years means we're going to do a normal CDF. And our boundaries, we want greater than 11.5. So our left is 11.5. For right, we're going to use something really big. I'm going to use 5,000 just because it sounds good. Our mean, which is 11.25 years. And then our standard deviation is 1.75, but we need to divide that by 90 since we are given the sample size. So it's 1.75 divided by the square root of 90. That's what you're going to punch in, and you get about 0.088 as your probability there. Between 11 and 11.5, going to be the same thing, only my left and right are right there. So normal CDF 11, comma 11.5, comma the mean, comma 1.75 divided by square root of 90. I'm going to show this one done in action in case anybody wants to see it. Second vars, normal CDF 11, comma 11.5, comma 11.25, comma 1.75 divided by the square root of 90. Then you get 0.825. For number 9, over the years, this one, we've got a mean and we got a standard deviation. We've got 32 students. We want to know the probability of the average score is no more than 79. And again, normally distributed. So we'll find that probability by doing a normal CDF. My boundaries, no more than 79, so between 0 and 79. The mean is 82, and the standard deviation is 6, but because they give us the sample size of 32, we need to divide that by the square root of 32, which gives us a probability of 0.0023. Not a very good chance. They're going to do better. 10. A factory manufacturing tennis balls determines the probability that a single can of 3 balls will contain at least one defective ball is this. Probability a case of 48 will contain at least 2 cans of defective balls. So I want the probability of at least 2, which means I want the probability of 2, 3, all the way up to 48, which means I don't want the probability of 0 and 1. Okay, since I want the high end, I'm going to do 1 minus the low end, 1 minus binomial CDF. 48 total cans of balls, 0.025 probability of finding a defective. And since I want to get rid of 0 and 1, I'm going to put a 1 here and subtract out 0 and 1. Find the probability of being 0.338 for number 10. For number 11, we talked about this in class. In order for you to have 900 more heads than tails, there would have to be at least 950 heads. So if you're going to have at least 900 more, it'd be 950 up to 1,000 heads. All right, that's what I want. What I don't want is 0 to 949. So once again, I'm going to subtract 1 minus the binomial CDF. My total number of tosses is 1,000. My probability of success, flipping a coin and getting the heads, is 0.5. And I want to subtract out the bottom 949. This gives you a probability of 0. There is no chance you're going to get 950 or above in 1,000 tosses. Number 12, you read through it. What are the expected mean and standard deviation? Well, again, the mean is just n times p. Number of football players, scholarship athletes here, 55. probability of them graduating within 5 years is 0.2. You multiply and you get a mean of 11. 11 out of 55 players should, based on this data. Standard deviation, n times p times q, which is the square root of 55 times 0.2 times 0.8, which equals 2.97. And that is how you do that. On the last page, number 13, crabs off the coast of northern California have a mean weight of 2 pounds. This is another one where you asked for the sampling distribution. Again, that's just showing that you know that the standard deviation is divided by the square root of the sample size. So your mean, 2 pounds in ounces, would be 32 ounces. And your standard deviation would be 5 ounces divided by the sample size, which is square root of 35. 5 divided by the square root of 35 is 0.845. We'll not ask you how to do, or to do one like A. What would the probability of selecting 45 crabs with an average weight of no more than 34 ounces be? That's going to be a normal CDF. Now my boundaries, no more than 34, would be 0 to 34. The mean was given, it's 2 pounds, which is 32 ounces. And the standard deviation here would be my standard deviation, which is 5 ounces, divided by 45. Okay, so that would be, I'm going to punch that in, 5 divided by the square root of 45, which gives you 0.745. And now we're going to go second bars, normal CDF, 0, 0, 34, put that down. 0, 34, 32, 0.745. And we get a probability of 0.996. So very good chance of that happening. Number 14, probability a person recovers from a particular type of cancer operation is 0.7 because 8 people have the operation. Suppose 8 people have the operation. What's the probability that exactly 5 recover? That's going to be a binomial PDF, you should know, because we want exactly. Total sample size 8, probability of success 0.7. We want to know the probability of 5, about 25%. For B, they all recover. Again, that's going to be a PDF because we want to know the probability that exactly 8 recover. So our last number would be 8. Chances aren't good, unfortunately, 0.0576. At least one of them recovers. So I want the probability. I want 1 to 8, which means I don't want 0. So I'm going to do 1 minus binomial CDF of 8, 0.7, and I want to subtract out 0, so I'm going to put a 0 there. And there's a 0.9999 chance that at least one recovers. Final question. After the Challenger disaster in 1986 was discovered the explosion was caused by a defective O-rings, the probability a single O-ring was defective and would fail was 0.03, and there were 12 of them. What was the probability that at least one of the O-rings would fail? Well, I want the probability at least 1. So again, I want 1 to 12. I don't want 0. Well, I do want none to fail, but in this case, I want to know the probability. So, since I want the high end, once again, why not 1 minus the binomial CDF? 12 total O-rings, probability of fail is 0.003, and I want to subtract out the probability of 0. So what is the chances of this disaster happening? They're actually higher than they should be. You get this, there's about a 3.5% chance of failure, and that's what happened. That is your practice test. Come in the morning with questions. I will be here.